I'm Seth.
Seth is an experienced machinist, a Fusion user since 2014, and loves helping people use Fusion for manufacturing.
A question came up for designing fillets for machining. Right now, I'm struggling to modify my designs so they are easier to machine. I have a lot of interior corners that parts need to fit into. Some of them I can do with a simple dog bone fillet for, but some of them are curved and not even in the plane I intend on them being machined in. So far, I've been using the parallel and perpendicular sweep tool a lot with both profiles and solids, but it really doesn't like to behave. Any advice would be appreciated. So, Feeling Broccoli 814, let's take a look at some aspects of your question. There's a lot of design baked into this question, but there are some considerations for manufacturing, as you suggest in your question. On the design side of things, you mentioned using parallel and perpendicular sweep tool a lot. I would probably not make that my first attempt. Usually the fillet tool in Fusion is pretty solid. But then there are some cases where simply doing a cut combine process, a Boolean combine operation with keep tools and cutting, so you can select your tool, you can select your target, enable the keep tools because you don't want to get rid of the part that you just used to remove a bunch of material. And then you can end up with a nice, perfect impression, much like sticking your hand in clay or snow to make a nice little imprint. So you can do that. There's also the Boolean sweep command. So you take the model, select the target, which direction you want to go, and it's going to remove everything along that path. So those are some things you can consider. Usually the only times I start bringing sweeps into things is when, okay, that fillet is not tangent at all and I need it to be, I will sketch something and then do a sweep along a curve. But that's usually the exception, not the rule. Are we making fillets for proper mating of a part into a vise, in which case we need to respect what is being specified on the customer supplied fillet or the print. And then the other question is, okay, is this for clearance in jaws or is this machining fillets into parts? Like if we are machining fillets into fixtures just to allow our part to fit, we don't really care. We can do a quick little dog bone and just haul the material out. And it doesn't even need to be very accurate or elaborate. We can just do a quick, simple sketch and turn a square pocket into something that comes out. If it's fillets on a part that you've designed, I would strongly encourage you to model your fillets to the tooling you plan to use. If you're an American, quarter-inch fillet, you do not want to use a half-inch end mill because you're going to have an end mill coming into a sharp corner effectively and then doing a 90-degree directional change. This will lead to chatter, excessive amounts of pressure on your tool, and if your tool is of an excessive length, it could likely break. So you want to cut down on that. So ideally, you want to be less than 2/3 of the radius. So if you've got a quarter-inch radius, I would likely come into it with a 3/8 end mill. So that's 187 radius. Same deal goes for fillets in the bottom of a feature. If I've got a half-inch end mill coming into a quarter-inch radius and cutting on the wall, I may end up with some undesirable results. I would much rather get in there with like a 7/16 ball end mill or a 3/8 ball end mill, or even swapping countries and going with like a 10 millimeter ball end mill. So it's okay for an American person to use metric tools. We don't just suddenly burst into flame. You seldom want to go to the actual size of the fillet. There are some exceptions, like if I'm doing some really tiny filleting and it's a 60 thousandths fillet, I'm probably not going to size down to a 45 thousandths radius. I will go to that size. But the bigger the size becomes, the more you really have to consider, do I want to do this?